Hello dear students. Today we are back with an interesting topic which sounds very easy for some of us, writing and balancing a chemical equation. But my experience shows that if a child gets put off by this topic, they tend to just hate chemistry and they don't enjoy it as a subject. So we are taking this very simple topic, writing and balancing a chemical equation. First of all, let's break it down. What is a chemical equation? Chemical equation is nothing but the symbolic representation of a chemical change. That means when a chemical change happens and we represent it with the help of symbols for the elements and the compounds, it becomes a chemical equation. For example, I've got a chemical change happening where we've mentioned sodium reacts with water to form sodium hydroxide and hydrogen gas. Now if you see over here, if you have to represent every chemical change with a long sentence like this, there are many issues that crop up. One, of course, it is long and time consuming, but then at the same time there is the dialect, there is the language barrier as well. Whereas chemistry is a universal knowledge. So we try to simplify it. Instead of saying reacts with water, that means we put a plus sign. To give, in order to represent to give, we put an arrow over here. What we write on the left hand side are what we call as reactants. That means substances which will undergo a chemical change. While on the right hand side, this side, we write substances which are formed as a result of chemical change known as products. The reactants and products are separated by an arrow pointing from the reactants to the products. Sometimes you will find arrows like this, meaning to say that the reaction is reversible. In other words, the reactants are forming products, but the products also can get from the reactants back under the same conditions. That means it's a two-way process. Anyway, we shall not be talking about it right now. What we are going to do is we will again simplify it because sodium plus water. Now this sodium, different languages have different spellings and writings. So as I said, chemistry is a universal language. So what do we need is, we need to simplify it further. So we introduced what we call as the language of chemistry, where the elements are represented by symbols. A note on this has already been provided in the earlier videos. If you are unaware of that, I request you to go through those. So coming down to sodium Na plus water H2O, sodium hydroxide NaOH plus hydrogen gas. Now hydrogen as an element, you know that the symbol is H, but you will be wondering why we are writing H2. You also know that an atom cannot exist independently in nature. So hydrogen plus hydrogen, hydrogen always exists in groups of two. That is how it will exist as a hydrogen gas. We are not saying a hydrogen atom. We have hydrogen gas being liberated over here. So H2. This becomes a chemical equation, symbolic representation of a chemical change. Next comes balancing. What is balancing? Let's see first this equation. Sodium, 1 atom of sodium, 2 atoms of hydrogen. So I will list it here. There is 1 atom of sodium here. There are 2 atoms of hydrogen over here. There is only 1 atom of oxygen here. Sodium here is 1. Hydrogen is 1 plus 2 atoms of hydrogen over here. So 2 plus 1 makes it 3 for us. And oxygen is 1. So this equation, where you notice that the number of atoms of each type are not same on both sides. So sodium 1, 1. Hydrogen is 2, but hydrogen is 3 over here. So it's not a balanced equation. This type of an equation is what we call as a skeletal equation or an unbalanced equation, where the number of atoms of each type on both sides are not the same. So we have to try and balance them. Why do we have to balance them? Why to go all the way to balance them? We know a law, which is the law of conservation of mass. That means you can neither create mass, neither can you destroy it. It will only change its form. Law of conservation of mass. Mass can neither be created nor be destroyed. It only changes its form. Sodium is an atom over here. It is existing as an element over here. But when it forms sodium hydroxide, it is forming a compound. So it has changed its form from an element to a compound. Hydrogen is existing as H2O in the reactant side. So two hydrogen combined with oxygen. Whereas here it comes into the elemental form as H2 and an atom of it exists as the molecular form of NaOH. So we need to, due to this law of conservation of mass, in accordance with the law of conservation of mass, we need to balance this chemical equation. So let's start doing it. We've already listed sodium, hydrogen, oxygen, sodium, hydrogen, oxygen. Now if you notice over here, hydrogen is the unbalanced thing. I cannot simply say, okay, if hydrogen is 3 on the right hand side, I'll just write water as H3O. No, that becomes absolutely wrong, because you are changing the formula of it. You are changing the standard formulation of it. When you write it as H3O, it no longer remains as water. So we cannot write it like this. I cannot write a number outside it also, because that also changes the entire meaning of it. So I have to write a number so that it brings me equal to the number of hydrogen atoms on the right hand side, or some permutation and combination so that the number of atoms becomes equal. Let's start with the smallest number possible, 2. So when I write 2 over here, 2 times 2, now this means 2H2O. There are 2 atoms of hydrogen multiplied with this 2. What does it give me is, it gives me the total number of hydrogen atoms as 4 on the left hand side. So this is 4. Whereas if you notice over here, the number of hydrogen atoms is still 3 over here. At the same time, the number of oxygen atoms has now become, this oxygen is 1. 1 times 2 becomes 2. So number of oxygen atoms is 2, whereas number of oxygen atoms on the right hand side is only 1. So what do we have? What option do we have? Let's try and make this 2. How do we make this 2? As I said earlier, we cannot write a 2 outside it. We can write a 2 before it. Now sodium becomes 1 times 2, that is 2. Hydrogen now becomes 2 times 1, that is 2, plus 2 makes it 4. So instead of 3, I will have 2 plus 2 gives me a total of 4. Oxygen is 1 times 2, that is 2. Now on the right hand side, I have sodium 2, hydrogen 4, oxygen 2. On the left hand side now, sodium still remains 1, whereas sodium on the right hand side has become 2. So let us make this also 2 by putting a 2 before it. So sodium becomes 2. Sodium 2, sodium 2. Hydrogen 4, hydrogen 4. Oxygen 2, oxygen 2. If you notice over here, all the atoms have become equal on both the sides. This is what we call as a balanced chemical equation, an equation in which the number of atoms of each type on the reactant and product side is same. And we do this in accordance with the law of conservation of mass. Let us take another example. Here we've taken calcium plus water gives us calcium hydroxide and hydrogen. Now in order to balance this equation, and why I have taken this equation is because there's a bracket OH whole twice. When we say OH whole twice, this means that in this formula, calcium is 1, oxygen is 2, hydrogen is 2. I'm talking about this formula. Overall, on the right hand side, the number of hydrogen atoms is 2 here plus 2 here makes it a total of 4. On the reactant side, on the other hand, we have calcium as 1, hydrogen as 2, oxygen as 1. As you can clearly see, the equation is unbalanced. It's a skeletal equation. We need to equalize the number of atoms on both sides. Hydrogen is 4, hydrogen is 2. Can you think of a number with which I should multiply 2 in order to get 4? Yes, 2 times 2 gives me 4. So let me try and put a 2 over here. When we put a 2 over here, that means 2 water molecules are reacting with 1 atom of calcium. So 2 water molecules means the number of oxygen also becomes doubled, and I have number of oxygen atoms as 2 over here. Let us see our equation. Calcium 1, calcium 1. Hydrogen 4, hydrogen 4. Oxygen 2, oxygen 2. So this equation becomes balanced for us. Would you like to try and balance the third and fourth equation yourself? It is very easy. You just have to be careful about the atoms of the same type in different forms. So if you see over here, chlorine is 2 and there is 2 chlorine over here as well. So there are 4 chlorine atoms. So just pause the video, try balancing it yourself. You will gain confidence in balancing a chemical equation. You can always start the video or continue with the video in order to check your answer, because we will go ahead. It is not necessary that every time we put the elements in listed format like this, so calcium, hydrogen, oxygen. We are advancing to the next level, and what we have is manganese 1, manganese 1. So for balancing, you just need to have a pencil and an eraser in your hand. Don't start with a pen right away, because if you scribble, it becomes a little unpresentable. So manganese 1, manganese 1. Hydrogen 1, hydrogen 2. There's no other hydrogen. Let me try and make this hydrogen as 2. Chlorine 2. Chlorine 2 plus 2 gives me a total of 4. So my chlorine is still short over here if I put a 2. The next possible option, the next best option to me appears to be 4. Now if you notice over here, 4 hydrogen, but there are only 2 hydrogen on the right hand side. So well, let's try and make it 2 times 2, that is 4 hydrogen on the right hand side. 1 manganese, 1 manganese. 2 oxygen, 2 oxygen. 4 hydrogen. 2 times 2 is 4 hydrogen. 4 chlorine. 2 plus 2 is 4. Remember, when I am putting a number before the formula, it gets multiplied with all the subscripts. Whereas when there's a plus sign between two formulas, the numbers will simply get added. So it's 2 plus 2 gives me a total of 4. Same way over here, when we did for sodium hydroxide, 2 times 1 is 2 plus 2 gives me a total of 4. This 2 will not be multiplied by the 2 of the hydrogen over here. So we have MnO2 plus 4HCl gives me MnCl2 plus 2H2O plus chlorine. So you can give yourself a star if you got this equation right, because just by understanding two equations you've been able to manage balancing a chemical equation. If not, don't get disheartened. Each mistake is a learning. So let's go on to the fourth equation. ZnNO3 whole twice gives zinc oxide, nitrogen dioxide and oxygen. Now, again I've taken this is to make you understand the meaning of this ZnNO3 hold twice. Here zinc is 1, nitrogen is 2 times 1, so 2. Oxygen is 3 times 2, that is 6. This is what you have to keep in mind when balancing this equation. So nitrogen over here are 2. How many nitrogen do we have on the right hand side? 1. So let's balance it, put a 2 over there. Oxygen is 6 over here, whereas here we have 1 plus 2 times 2 is 4. 4 plus 1, 5 and a 6 and a 7. We have 7 oxygen over here. So that means our equation is not balanced. The smallest number that I can put in front of zinc nitrate is 2. That makes my zinc as 2. So we need to increase the number of zinc atoms also over here, makes it 2. When we have put a 2 over here, we've got nitrogen 2 times 2 makes it 4. So there comes in our eraser and we will rub out the 2 from here and make it as 4. Now let us see. Zinc 2, zinc 2, nitrogen 2 times 1 2, 2 times 2 is 4, 4 nitrogen. Oxygen 3 into 2 6, 6 times 2 is 12. Oxygen 2 plus 4 times 2 is 8 plus 2 oxygen over here gives us a total of 12. So if you notice over here, your number of atoms on both sides has become equal. So we have 4 nitrogen, 2 zinc and 12 oxygen on each side. On the website Learning Chemistry is Fun, I've added some more worksheets for you to practice. I would advise that you practice minimum 10 equations in order to get a hang of this. Don't get disheartened if you don't get it in the first go. It happens with many of us, me including. But success lies only not giving up anything that you are doing. How can we make an equation more informative? So let us suppose I have an equation. The first one, sodium plus water gives me sodium hydroxide plus hydrogen. Here I don't know what is the state of sodium, water, in what form am I taking. Water can exist in the form of a solid, liquid or gas. So what form of water is reacting with sodium? In order to make the equation more informative, we try and write the state of the compound or the element in brackets. So sodium existing as a solid, water reacting as a liquid. Sodium hydroxide is being formed in a solution over here. So we can write it as NaOH and in the brackets we will write AQ. AQ stands for aqueous. That means a solution in water. Hydrogen will be liberated as a gas. So we write a G. Supposing if a substance is formed as a precipitate, so there are reactions you will come across. So FeOH holds twice. It is forming as a precipitate in a reaction. So there what you will do is, if we are taking an example over here, Fe2SO4 holds thrice plus NaOH. I am not balancing it here. FeOH holds thrice. Now this is forming as a precipitate. Precipitate means an insoluble solid. So that we will represent as an S in brackets, indicating that it is separated out of the solution. It's an insoluble compound. We can also make an equation more informative by mentioning the temperature, the pressure, the catalyst involved during a chemical reaction. Now this particular reaction is taking place at room temperature, at normal temperature. Even normal cold water will react with water. That is how fast this reaction is. So we will not mention it over here, but there are reactions where you mention the temperature, 250 to 300 degrees Celsius, pressure, catalyst. What is the information that I am not getting from a chemical equation? We know that sodium reacts with water to give sodium hydroxide and hydrogen. We also know that iron also reacts with water. Have you ever experienced iron reacting with water? Can you think of an example? It's a daily life example. Yes, the formation of rust. There also, iron is reacting with water in the presence of oxygen from the air to give us rust. There are three reactants over here: iron, water and oxygen. Now, but if you notice, rusting doesn't happen immediately. It's a slow process. But an equation does not convey that to you very clearly. Same way, sodium reacting with water, it's just a matter of seconds. Sodium is so reactive that if you hold it between your fingers, it will even react with the moisture of your hand, and you will have a burning sensation and a slimy feel because of the formation of sodium hydroxide. All this is not conveyed by a chemical equation. Feasibility. Yes, a chemical reaction will take place, but how fast, how slow, in how much time, in how many years will it actually happen or no? There are reactions which are supposed to happen, but because of energy considerations do not take place completely or without initiation. So all that information cannot be obtained from a chemical equation. Let me know your feedback on this or any other help that you need. Please subscribe for more videos to Learning Chemistry is Fun. All the best.